In this video, I'll start discussing decision making in Python, and for that purpose I'll introduce the if statement and Python's comparison operators. Now, when you're trying to make decisions in a program in Python, you need to have a Boolean expression, which is any expression that evaluates to either true or false. And as you'll see as we proceed through these videos, Python is very flexible in what you can treat as true or false. For this example, we'll focus on numeric values, but as we go forward, we'll show you lots of different things that can be treated as true or false in Python. So the key thing that we need in order to make a decision is a condition, a Boolean expression that evaluates to true or false. There's actually true and false keywords in Python that are reserved for use by the Python language itself, so we'll start to use those going forward as well. But first, let's just take a look at a simple expression, 7 greater than 4. Here we have two integer values, 7 and 4, and we're trying to determine whether 7 is greater than 4, which of course it is. So when I evaluate that, I see that IPython gives back, or displays rather, the value true, which is the text representation of the true value, the true Boolean value in Python. Similarly, of course, there's a less than operator, so 7 is not less than 4, therefore we expect when we evaluate this to get the value false. There's a number of different operators available to you, comparison operators specifically. So we just demonstrated greater than or less than, which look the same both in Python and algebra. But for these other algebraic operators in Python, we represent them a little bit differently. So for greater than or equal, we have two symbols, the greater than sign and the equal sign. No space between any of these last four operators that we're displaying here, otherwise you'll wind up with a syntax error. So greater than or equal, less than or equal. For equality, we use two equal signs. This comes from the C programming language originally, and similarly for inequality, we use the exclamation point and an equal sign to represent not equals. Those are the basic comparison operators, and in order to introduce the if statement in this example, we're actually going to demonstrate our very first script, or if you will, full Python program. So for that purpose, I'm going to exit the term IPython interpreter here, and I'm just going to type ls so I can show you that once again we have some files in the current folder. I'm assuming you're still working within the ch02 folder of the examples. And this first file that I've highlighted here is actually a Python script that has a bunch of if statements in it that are going to make some decisions. So before I show you the code, I'm actually going to execute this program so that you can see it in action. And the way that you execute a script, if you recall from lesson 1, is using the IPython command followed by the name of the file. So I'm going to use some auto completion here, and you can see that it doesn't fully fill in the name of the file because I have a couple of files that start out similarly here. So if I go ahead and type 1, there's only one file name that starts out with what I've typed so far. So if I hit tab, it'll now fill in the rest of the name for me. If I go ahead and hit enter, it'll run my script, and you can see that the script is prompting me with some text. Enter two integers and I will tell you the relationships they satisfy. So let's say we type 37 and 42 in this case, and I'll go ahead and press enter, and we can see that 37 is not equal to 42. That seems reasonable. 37 is of course less than 42, and because it's less than, it's also less than or equal to 42 as well. Let's recall that last command and execute the script again. And this time let's enter 7 and 7, which of course are equal. And you can see I get three results once again. 7 is equal to 7, it's less than or equal to 7, and it's greater than or equal to 7 as well. And finally, let's execute this one more time, and this time we'll make the first number that we enter larger than the second number. So we can see that once again the numbers are not equal. 54 is greater than 17, and it's also therefore greater than or equal to 17 as well. Now that we've seen how the program actually works, I'm going to switch over to a text editor and show you the contents of this first script that we're presenting to you. Now, when you're writing Python code as scripts, you can use pretty much any text editor that you'd like. I happen to like this TextMate application here on my Macintosh computer, but any text editor will do. And again, going back to the before you begin lesson for a moment, when you install the Anaconda Python distribution, one of the things that you get is the popular Spider integrated development environment, so you can certainly use that if you would like. You also get the option of installing the Visual Studio Code editor from Microsoft, which is a cross-platform coding environment that you can get for Windows, Linux, and Mac OS. Once you have your editor of choice, most code-based editors provide syntax coloring for your Python code. So you can see there's various different colors being displayed on my screen at the moment. Now, for every script that we present to you, we typically like to put what's known as a comment at the beginning of the script containing the file name for that script, and that's so that you can find the code in our code downloads. So within the ch02 folder there is a file named fig02_01.py that corresponds to an actual figure number in our corresponding books. So this is just how you'll find the code on disk so that you can work with it as well. Now, anytime you see the hash symbol, or what some people refer to as the pound sign, that is what's known as a comment in Python. Python comments start at the hash symbol and go to the end of the current line only. And you can have multiple comments in a row if you need to create a block comment. You can also put comments like this at the ends of lines of code as well. By the way, the line numbers being displayed by my editor over here at the left side are not part of Python. They are simply there for your convenience in the editor so that you can refer to lines of code as you're reading through the text of the script, and similarly as you're following along with my presentation as well. Now, the style guide for Python code recommends that anytime you create a script, you begin that script with a triple quoted string, which in this case is a doc string, a documentation string explaining the purpose of that script. So here we have a simple doc string that's one line of text. Compare integers using if statements and comparison operators. Now in later lessons I'll show you that those doc strings are capable of being used by things like the IPython interpreter and integrated development environments to provide help to you or whoever happens to be using your code. So those doc strings, by the way, can contain many lines of text. Remember that triple quoted strings can be broken across lines of text, and it's not uncommon to see very long doc strings for things like libraries of code that you're distributing for other people to use, or more complex scripts. In this case, we simply want to compare some integers. Now, the next thing that we're doing here is a print statement that's going to display the initial instructions that you saw when I ran the program. And you'll notice here that the print statement has two strings in it here, separated by a comma. We chose this approach in our script here because it was a rather lengthy string and we wanted it to display on one line. However, when we're writing code to display in textbooks, we have only a certain number of characters of width to work with, and this string was too long for that width. So we put two strings separated by a comma, and that will result in one line of output with the two strings separated by a space. And remember, the print function also automatically outputs a new line character. Next, we have another comment stating what the next line of code is going to do. It's going to read an integer from the user. And we have a line of code that you saw similarly in an earlier video, where we are going to use the built-in input function to read a number from the user. We're telling the user what to do, enter first integer. The input cursor will appear to the right of this space character, waiting for the user to type something and press enter. That string will then be given back to my script and handed to the int function, which is going to convert the string to an integer. Now, in this simple script, I'm assuming the user properly enters an integer value. You saw earlier that if you give it a non-integer, like the string hello, that cannot be converted from the string into an integer, then you wind up with an exception at runtime, specifically an exception of type value error. So assuming the user types a proper integer value, number 1 will then represent that numeric value in memory. And we're doing the same thing again down here at line 11, asking the user to enter a second integer. Blank lines can be used to make your code more readable. They have no effect on the execution of the script in Python. Now, next up, after reading in the two numbers, we have a sequence of 6 separate if statements. And here is where things start to change from other programming languages that you might be familiar with. First of all, let's talk about this first if statement. Every if statement used to make a decision is going to start with the keyword if. The vast majority of Python keywords are all lowercase letters, as is the case for the if keyword here. And following the if keyword, you have some sort of expression that's going to evaluate to either the Boolean value true or the Boolean value false. Now, unlike some other programming languages, the expression that you write here does not need to be enclosed in parentheses. You can use them if you like, but they are not required in Python. However, the colon is required, and the colon introduces what is known as the if statement's suite of code. The suite of code is an indented block of code in which you have statements that should execute only if this condition, number 1 is equal to number 2, evaluates to true. If that condition is true, we will execute all of the statements that appear in the if statement suite. If that condition is false, we will skip the body, the suite, and move on to the next statement below that in sequence in our script. Now, Python is very picky about indentation. When you indent your suite, you can use as many spaces as you want, though 4 is the standard convention that we use throughout the book and that most people use in Python. And separately, you have to do the indents exactly the same for every line of code in a given if statement suite. So if I use 4 space characters to indent this print statement here, and then I want to create another line of code inside this if statement to execute only if the condition is true, I must use 4 spaces once again. I can't use a tab character, I can't use 3 spaces, I can't use 7 spaces. It must be 4 spaces, otherwise the Python interpreter will give you an indentation error. So that is something that you'll have to get used to in Python. However, it leads to relatively clean and simple code, because you'll notice here in Python, unlike many C-based programming languages, we don't have any curly braces to deal with in our control statements. So if number 1 is equal to number 2, we're going to execute, the print statement here on line 14, which is going to display the value of the variable number 1, which is an integer. It's going to separate that integer by a space from the string is equal to. Remember, when you comma separate a bunch of values. In print, it separates each one by a space. Then we're going to display the string is equal to, and then we're going to follow that by another space and the value of the variable number 2. So we already saw the results, of course, of doing this. Now we're just seeing what produced those results. Now, of these 6 if statements, which are all quite similar, only 3 of them will ever evaluate to true, and that's why we always got 3 lines of output as we executed this script each time. So the main difference between each of these 6 separate if statements is that in the second statement we use the not equals operator. So this will be true if the 2 numbers have different values, and in that case we'll output between them is not equal to. And similarly, we have the less than operator, the greater than operator, the less than or equal to operator, and the greater than or equal to operator as well. Now, one other side note before we continue with this particular presentation and video, and this has to do with the double equals operator versus the single equal sign assignment symbol. So a lot of people in C-based languages confuse 1 equal sign with 2 equal signs. Whenever you have 2 equal signs back to back, that is an operator that will produce a Boolean value of true or false. Anytime you have a single equal sign, that is an assignment, and it's going to assign a value to the variable on the left-hand side of the equals symbol. So now that we've taken a look at this script, let's talk a little bit more about conditions in Python. In particular, I want to talk about chaining comparison operators. So I'm going to switch back over to my terminal window once again here, and let me jump back into, actually let's clear the screen here, and we'll jump back into IPython for a new session here. And one of the things that makes Python a little bit different from some of the other C-based languages out there is it provides a number of convenience notations that make it really easy to write certain types of expressions. Now, to help me out with this, I'm going to start by declaring a variable x that contains the integer value 3. And if I wanted to say, let's check whether x is greater than or equal to 1 and less than or equal to 5, in most programming languages, I would have to write 2 physically separate expressions to test those 2 different cases, and then I'd have to join those results together using what's known as a logical operator, a logical AND operation. And we'll introduce logical operators in the next lesson, but here I want to show you that you can actually use chained comparisons to do some interesting testing here in Python. So if I want to know whether x is inside the range 1 through 5, I can write an expression like this, which says check to see whether 1 is less than or equal to x and whether x is less than or equal to 5. So that's similar to the expression I was stating before I typed this, which is to check whether x is greater than or equal to 1 and x is less than or equal to 5. And in this case, we can see that indeed x is inside of that range. Now, if I change the value of x, let's say we make x 10 now, and now if I recall the expression that we just did up above, of course x is not going to be less than or equal to 5 after I make this modification. So now we see that we get false. So x is not in the range 1 through 5 as a result of changing x's value up above. So that is a nice convenience notation for chaining together comparison operators. And just one last thing before we move on to the next video, which is there are lots of different operators in Python, and for this discussion let me just switch over to my browser window here, and I've already opened up the expressions page of the documentation on the Python website. And if you scroll down to the bottom of the table of contents for this page here, you'll see that there is an operator precedence link. which brings you down to the operator precedence table at the bottom of the page. Now, in this operator precedence table, they've listed for you the operators in order from lowest to highest precedence. So the highest precedence operators are down at the bottom here. But what you'll want to do is just be aware that this table exists, so that as you learn more and more of the operators that are available to you in Python, you can check this table and make sure you understand how the precedence of those operators relates to one another. Now, whenever you have expressions that contain lots of these operators, the operators evaluate in a given expression from left to right, with one exception, which is the exponentiation operator that we introduced previously.